You are welcome back to the channel where mathematical literacy begins. This is God Maths. I believe our previous lessons have been useful. In today's lesson, we will look at the basics of trigonometry. If you have not hit the subscription button yet, please do, and stay tuned for more interesting lessons. Trigonometry as a branch of mathematics deals with the study of the relationship between the sides and the angles of a triangle, together with some other functions. In today's lesson, we will look at the right-angled triangle, from which we will discuss the three basic trigonometric ratios: the sine, the cosine, and the tangent. Let's get started. A triangle is a plane figure which has three sides and three angles. A right-angled triangle is a special type of triangle where one of the angles inside that triangle is 90 degrees. And so, if we have any triangle that is a three-sided figure where one of the angles inside the triangle is a right angle or is equal to 90 degrees, then we say that that triangle is a right-angled triangle. So in these two triangles, we have 90 degrees and then we have 90 degrees. It may also be represented as 90 degrees. Then we know that that triangle is a right-angled triangle. Now in this triangle, the longest side, which is the side that faces the angle 90 degrees, is called the hypotenuse. So in the second triangle, this is the side that faces the angle 90 degrees, and that is the hypotenuse. In this triangle, this side faces the angle 90 degrees, and it is the hypotenuse. The two other sides of this triangle are called the opposite and then the adjacent, depending on where a certain angle is located. So suppose in this triangle we have an angle theta here, then the side that faces this angle theta or is directly opposite to this angle theta is what we call the opposite, and then the other side is called adjacent. Now in the next triangle, if we decide to represent this angle by theta, then the side that is opposite to theta is called the opposite, and the other side is called adjacent. Now, in a right-angled triangle, the Greek philosopher Pythagoras was able to ascertain that the square of the hypotenuse is equal to the sum of the squares of the two other sides. So, suppose the hypotenuse is h, the adjacent is A, and the opposite is B. Then Pythagoras was able to ascertain that in any given right-angled triangle, h squared is equal to a squared plus b squared. This is referred to as the Pythagoras theorem. And it is true for any given right-angled triangle. Now, for a right-angled triangle, the trigonometric ratios sine, cosine, and then tangent can be found using the sides adjacent, opposite, and then hypotenuse. The sine of any angle theta inside a right-angled triangle is given by sine theta is equal to the opposite over hypotenuse. The cos of the angle theta is given by cos theta is equal to the adjacent over the hypotenuse. And then the tangent of the angle theta is given by tan theta is equal to the opposite divided by the adjacent. Now, in this lesson, we will look at how to apply these three trigonometric ratios and other higher trigonometric ratios. Let's take our first example. In this example, we have to write down the ratios sin theta, cos theta, and tan theta from the diagrams below, the diagrams A and the diagram B. Now we have already established that given any right angle triangle, the basic trigonometric ratios are the sine of the angle is equal to the opposite divided by hypotenuse. The cos of the angle is given by the adjacent divided by the hypotenuse, and the tan of the angle is given by the opposite divided by the adjacent. We will use these trigonometric ratios to solve the question. Now in diagram A, we want to write sin theta, cos theta, and tan theta. So sin theta, which is given by the opposite over hypotenuse, will be, let's discover the hypotenuse, the opposite, and then the adjacent. So the longest side, which faces 90 degrees, is the hypotenuse. The side which faces the given angle is the opposite, and then the other side is adjacent. So sin theta, which is opposite over hypotenuse, will be equal to, the opposite is 4, the hypotenuse is 5. Then cos theta will be given by the adjacent divided by hypotenuse. So that will be equal to, the adjacent is 3, hypotenuse is 5. And then tan theta, which is given by the opposite divided by the adjacent, will be equal to, the opposite is 4 and the adjacent is 3. So 4 on 3. Then now to the second question. B. We still want to write the trigonometric ratios sin theta, cos theta, and tan theta, where theta is given. So the angle that faces theta is called the opposite. The longest side is called the hypotenuse, and the other side is called the adjacent. Now, from Pythagoras' theorem, we can find the longest side. Pythagoras' theorem states that the square of the hypotenuse is equal to the square of the sum of the two other sides. So 5 squared plus 12 squared. So the square of the hypotenuse is equal to the sum of the square of the two other sides. That is Pythagoras' theorem. So h squared will be equal to 25 plus 144. H squared will be equal to 169, where we take the square root of both sides, and then h will be equal to 13 units. So the hypotenuse is 13 units. Then now sin theta will be equal to the opposite over hypotenuse. So that is 12 over 13. Cos theta, which is the adjacent over hypotenuse, will be 5 over 13. And then tan theta, which is the opposite over adjacent, will be 12 over 5. We will take our second example on this. This is our second example where we have to use trigonometric ratios to find the values of x and y in the diagram and correct the answers to 1 decimal place. Now from this diagram, since there is 90 degrees in a triangle, this is a right angle triangle where the side which faces the 90 degrees is the hypotenuse, and then the side which faces the given angle is called the opposite, the other side is called adjacent. The trigonometric ratios are the sine which is opposite over hypotenuse, cos which is adjacent over hypotenuse, and tan which is opposite over adjacent. And so from this angle, we would say that the sine of the angle 30 degrees is equal to, the opposite is y and the hypotenuse is 15. So that is y over 15. So y will be equal to 15 times sine 30 degrees, and that is equal to 15 times sine 30. 15 sine 30, which gives us 7.5 centimeters. Then the adjacent, which is x, divided by the hypotenuse, is also the cos of the angle given. So cos 30 degrees is equal to the adjacent, which is x, divided by 15. And so x will be equal to 15 times cos 30. We multiply through by 15 by 15. 15 cancels this. And so x will be equal to 15 times cos 30. That gives us 12.9903, which is equal to 13.0 centimeters, since we are asked to correct our answers to 1 decimal place. Let's take our third example. Now, if sine theta is equal to 4 on 5 and theta is acute, we want to find cos theta, tan theta, and the value of the angle theta. So if sine theta is equal to 4 on 5, then it means that in that right angle triangle, the opposite to the angle theta is 4, and then the hypotenuse in that triangle is 5. Theta is acute means that theta is less than 90 degrees. Acute angles are less than 90 degrees. And so, if we draw this right angle triangle, where we have one of the angles to be 90 degrees, and the side facing the angle 90 degrees is called the hypotenuse, then from the question, the hypotenuse is 5. Now, if we represent this angle by theta, then the opposite to this angle is 4. So from this statement, sine theta is equal to 4 on 5, we can obtain this diagram where sine theta is equal to the opposite divided by the hypotenuse. From this diagram, we can also find the other side, which is the adjacent, using Pythagoras theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the two other sides. And so, applying Pythagoras theorem, we will have 5 squared to be equal to 4 squared plus b squared. We want to find the other side, which is b. Then from here, 5 squared is 25, and that is equal to 16 plus b squared. So grouping like terms, 25 minus 16 is equal to b squared. 9 is equal to b squared, and taking the square root of both sides, we will have b is equal to 3 units. Now, cos theta is equal to adjacent divided by hypotenuse, and so cos theta will be equal to 3 divided by 5. Then tan theta is equal to the opposite divided by adjacent, so tan theta will be 4 on 3. Then the last is for us to find the value of the angle theta. Now, if we are given sin theta is equal to 4 divided by 5, then the angle theta is equal to the sine inverse of 4 divided by 5. That is to say, we are dividing both sides by sine, but because sine is not a figure but a ratio, we take the sine inverse of what we have at the other side of the equation. And so, we find the sine inverse. On the calculator, sine inverse is shift plus sine. So sine inverse of 4 on 5. And that gives us 53.13 degrees. Now, since we have cos and then tan, we could have also used cos theta or tan theta to find the value of theta. Let's verify that. So from this, theta will be equal to cos inverse of 3 on 5, and that is also equal to 53.13 degrees. Then, since tan theta is 4 on 3, theta is equal to the tan inverse of 4 on 3, and that is also 53.13 degrees. So, using cos theta, tan theta, or sin theta, we can find the value of theta by taking the inverse of whichever ratio we are using. Let's take another example. Given that tan alpha is equal to 15 on 8, where alpha is greater than 0 but less than 90 degrees, which means that alpha is an acute angle. We want to evaluate sin alpha plus cos alpha all over sin alpha tan alpha. So, if we are given that tan alpha is 15 divided by 8, then it means that in a certain right angle triangle, the side of length 15 units is opposite to the angle alpha, and then the side of length 8 units is adjacent to the angle alpha. This is because tan is the ratio of the opposite to the adjacent. And so, we are able to represent this on a diagram where we have 90 degrees in a right angle triangle. The side facing 90 degrees is called the hypotenuse. Then the side which faces the given angle alpha is the opposite, 15, and then the other side is the adjacent. Then from Pythagoras' theorem, which says that the square of the hypotenuse is equal to the sum of the squares of the two other sides, we are able to find the hypotenuse, which is the longest side, to be 17 units. Then we represent that on the diagram. From there, we can obtain the ratios sin alpha and cos alpha from the diagram. Sin is the opposite divided by hypotenuse, and then cos is adjacent divided by hypotenuse. Now, since we have sine, cos, and tan, we can evaluate this sin alpha plus cos alpha all on sin alpha tan alpha. So we put in the values of sine alpha, cos alpha, sine alpha, and then tan alpha to obtain this expression. Then we simplify it in solving fractions with the same denominator. So we add the numerator, and that gives us 23 divided by 17. Then that is all divided by the denominator, which is multiplying. So we multiply this and that. This is 225, and this gives us 136. So in solving fractions or in dividing fractions, we find the reciprocal and then change the division to multiplication as done here. 17 goes into 136, and that is 8 times. So we simplify from here, and finally the value of this expression is 184 divided by 225. Let's take another example. Find the value of theta, given that I, cos of theta plus 30 degrees is equal to 0.3652. And then the next one, sine of 40 degrees plus theta is equal to 0.9362. We want to find the value of theta, and we are given that cos of the angle theta plus 30 degrees is equal to 0.3652. Note that this is one term since it's in a bracket. So the theta of all this is equal to 0.3652. And in eliminating theta, or we said that if we have cos theta and want to find the angle theta, we take the cos inverse of what we have at the other side of the equation. So theta plus 30 degrees will be equal to the cos inverse of 0.3652. And the cos inverse of 0.3652 is 68.5801, which is equal to theta plus 30 degrees. We want to find the angle theta. So theta is equal to 68.5801 minus 30 degrees. This is also an angle, and that is equal to 38.58 degrees. We can also, with that one, sine 40 degrees plus theta is equal to 0.9362. So taking the sine inverse of what we have at the other side, we will have 40 degrees plus our theta to be equal to the sine inverse of 0.9362. Sine inverse of that is equal to 69.4229, and that is equal to 40 degrees plus theta. So theta will be equal to 69.4229 minus 40 degrees, and that gives us 29.42 degrees. I believe that with this method you can solve the second question on your own. You take the tan inverse of what you have at the other side, and then you make alpha the subject. Remember that we cannot expand any of these brackets because cos is not a variable or a number. It does not have any value, cos standing on its own. So we cannot expand this bracket. We'll take our last example for this lesson. Find the values of x and theta in the diagram below. So in this diagram, we have x and then we have an angle theta. We want to find the values of x and then theta. Now, it will be observed that x, theta, and then 8 centimeters are in a certain right angle triangle. So we can have this right angle triangle with x as one side, theta as an angle in it, 8 centimeters, and then the angle 90 degrees. So we have this right angle triangle from the diagram. Then we have another right angle triangle. This right angle triangle still having 90 degrees in it. Then this side is still 8 centimeters, and then the side here becomes x plus 6. That is all this side, and the angle 50 degrees in the triangle. We want to find the values of x and theta. Now remember that in this right angle triangle we have x and theta. Here we have only x and another side. So we can find the value of x from this right angle triangle, and then from there we use the value of x to get the value of theta. So since we have these two sides, where 8 is opposite to 50 degrees and then x plus 6 is adjacent, then we will use the tan. Since the trigonometric ratios are sine opposite hypotenuse, cos is adjacent on hypotenuse, tan is opposite on adjacent. So where we have opposite and adjacent, we use the ratio tan. So tan 50 degrees will be equal to, the opposite is 8 and the adjacent is x plus 6. Referring to our lesson on equations, we multiply through by x plus 6. Where x plus 6 cancel out. So we will have x tan 50 degrees, that is expanding this bracket, plus 6 tan 50 degrees, and that is equal to 8. Grouping like terms, we will have x tan 50 is equal to 8 minus 6 tan 50 degrees. So we can divide through by tan 50 so that x stands alone, and x will be equal to 8 minus 6 tan 50 gives us 7.1505 all over tan 50 also gives us 1.1917. So from this we will have x to be equal to 8 minus 7.1505 will give us 0.8495 all over 1.1917, and that will give us x to be equal to 0.71 centimeters, since the sides are given in centimeters. Then in finding the angle theta, since we now know that x is 0.71 centimeters, where x is adjacent to theta and then 8 centimeters is opposite, we have opposite adjacent, and so we use tan theta. So tan theta will be equal to, the opposite is 8 and the adjacent is 0.71. Therefore, theta is equal to the tan inverse of 8 on 0.71. We find that with the calculator, and theta will give us 84.93 degrees. Let's check out our assignment for today's lesson. Try this assignment on your own. You can send us your answers via our social media handles: WhatsApp, Instagram, Facebook, and Twitter. You can also contact us if you have any extra difficulty with this lesson. If you have not already subscribed to this channel, please do subscribe for more interesting lessons. In our next lesson, we will look at the application of trigonometry. See you in our next lesson.